Hello, my name is Justyna Lucznik, and I'm the Group Product Manager for Synapse Data Engineering and Synapse Data Science in Fabric. Today, I'm really excited to share with you our strategy and roadmap for Spark and data engineering. Let's get started with a quick recap of Microsoft Fabric that was announced and built today. Fabric is Microsoft's next-generation data platform that brings together all the different experiences required to build your end-to-end data project, starting from ingestion all the way through to reporting. Today, we'll do a deep dive into the data engineering workload and see what Fabric has to offer. Our aim is to empower every data engineer to be able to transform their data at scale using Spark and build out their Lakehouse architecture. To achieve this goal, we're going to be talking about 4 key product experiences. Firstly, we'll talk about the Lakehouse and show you how easily you can get started bringing together all your organizational data and sharing it out with the business for consumption. Secondly, we'll introduce you to the Spark engine, which is the backbone of the data engineering experience. We'll talk about the Spark runtime, various performance improvements, and the robust admin controls for managing your Spark workload. Next, we'll look at the data developer authoring experience that lets you explore your data, write and operationalize your Spark code. We'll highlight the features and benefits of notebooks, our VS Code extension, as well as the Spark Shop definition item to run your Spark applications. Finally, we'll touch on how all these different capabilities are integrated into the platform, meaning you always have a seamless experience in areas like monitoring, CI/CD, governance, automation, and more. Let's get started with the Lakehouse and its role into data engineering workflow. The Lakehouse is a new item in Fabric, which combines the best of the lake and warehouse in a single experience. With the Lakehouse, we strive to remove all the friction from ingesting, preparing, and sharing organizational data in the lake in an open format. The power of the Lakehouse is that once data lands inside, tables are automatically generated, which can be read by Spark, SQL, and Power BI. In fact, every Lakehouse comes equipped with a SQL endpoint that provides data warehousing capabilities, including the ability to run T-SQL queries, create views, and define functions. Every Lakehouse also comes with a semantic dataset, enabling BI users to build reports directly on top of the Lakehouse data. All of these different users can therefore collaborate on top of the same data stored in the lake with no data movement necessary. From a data integration perspective, the Lakehouse gives users a variety of ingestion options. Users can start out with very simple workflows like uploading files directly from their local machine. Data engineers who work in low-code tools can leverage data flows with its hundreds of connectors to output data into the Lakehouse. For copying petabyte-sized lakes, users can also leverage pipelines with the copy activity. Behind the scenes, all the data lands in one lake to unify the data lake that comes pre-wired to every Fabric workspace. However, users don't have to copy the data into one lake to be able to leverage it inside the Lakehouse. They can also use shortcuts to point to existing data elsewhere in Fabric or even in external storage accounts. By creating a shortcut, data shows up in the Lakehouse either as a file or a table, despite the fact it is physically elsewhere, such as an ADLS Gen 2 storage account or even an S3 bucket. Coming soon is the ability to apply file folder as well as table security in the Lakehouse. With one security, once permissions are applied, they're automatically synchronized across all engines, meaning that permissions will be uniform across Spark, SQL, and Power BI. Finally, shortly after public preview, the Lakehouse can be shared as a data product for consumption by the entire business. End users who want to use the Lakehouse for reporting or data science can easily discover all the Lakehouses they have access to inside the One Lake Data Hub. This is the Fabric Data Discovery portal for all data items. Now that we have a better end-to-end view of the Lakehouse, let's take a look at how someone can leverage the Lakehouse for their own data project. Today, we're going to take a look at how data engineers can leverage Fabric to build out a Lakehouse architecture. In this scenario, I would like to build a Lakehouse for my organizational marketing data to share with the business. I'm going to start out by creating a new Lakehouse artifact, going to give it a name, and then immediately land in the empty Lakehouse Explorer. The Lakehouse is a new experience that combines the power of the lake and warehouse and is a central repository for all Fabric data. I have a variety of options to bring data into the Lakehouse. I can simply upload files and folders from my local machine. I can use data flows, which is a low-code tool with hundreds of connectors, or I can leverage the pipeline copy activity to bring in petabytes of data at scale. Once my marketing data is in the Lakehouse, Delta tables are automatically created for me with no additional effort. I can easily explore the tables, see their schema, and even the underlying files. I would also like to add some unstructured customer reviews to accompany my campaign data. Since the data already exists in storage, I can simply point to it with no data movement necessary. To do this, I'm going to add a new shortcut, which allows me to create a virtual table and virtual files inside my Lakehouse. Shortcuts enables me to select from lots of different sources, including lakehouses and warehouses in Fabric, but also external storage like AWS Gen 2 and even Amazon S3. Since my customer reviews are actually in S3, all I have to do is select it as a source, specify the data's location, and populate all of my account information. On the next screen, I can give my shortcut a name, and that's it in terms of setup. Within seconds, I can see a shortcut created in the Files section, which is the messy, unstructured data lake portion of the Lakehouse. I can now explore the data in the Lakehouse and even open up the PDFs, despite the data still physically being in S3. Now that all my data is ready in the Lakehouse, there are many ways for me to use it. As a data engineer or data scientist, I can open up the Lakehouse in a notebook and leverage Spark to continue transforming the data or build a machine learning model. As a SQL professional, I can seamlessly navigate to the SQL endpoint of the Lakehouse, where I can write SQL queries, create views and functions, all on top of the same Delta tables. As I write a quick SQL query, I get results back instantly without needing to move any data. Finally, as a business analyst, I can simply navigate to the built-in modeling view and start developing my BI data model directly in the same warehouse experience. After adding relationships and measures to my data, I can generate a Power BI report in a single click. As I build out my report, I get amazing performance thanks to Power BI Direct Lake Mode. With Direct Lake Mode, Power BI can natively read the Parquet Delta format stored in one lake, meaning, again, no data was duplicated in the process. To conclude, in Fabric, data engineers have a frictionless experience building out their enterprise data lakehouse and can easily democratize this data for all users in the organization. Next, we'll focus on some of the key features and performance enhancements that Fabric provides for running your Spark workloads with little friction and in a performant manner. One of the most important aspects is the Spark runtime. The runtime is pre-wired to Fabric workspaces and contains an optimized distribution of Spark, its dependencies, and other key libraries. In the 1.1 runtime, we're including major updates, such as upgrading Spark to 3.3.1, Delta to 2.2, and Python to 3.10. A key feature of the runtime is the integration with Delta Lake, which is the open table storage format that Fabric has standardized on. Delta is what enables customers to work with a single copy of data across all of Fabric. Since all the engines have standardized on a single format, sharing data is completely seamless. Furthermore, all Fabric engines write Delta with V-order, meaning data is automatically optimized for Power BI reporting. Finally, for those users who don't use Delta today, you can also use the Load to Delta feature in the Lakehouse to convert common file formats and folders to Delta with just a few clicks. This will allow you to easily leverage the benefits of Delta Lake for your existing data as well. To ensure customers have a performant experience, we have also built various Spark optimizations into our runtime. These optimizations are designed to enhance your query performance by default without needing to do any configurations. One example is partition caching, which stores filtered partition information in a session-level cache. This means less calls have to be made to the metastore, saving you time and cost. Another example is merging scalar subqueries into a single plan, which again reduces the computation time. An exciting upcoming capability that also focuses on performance by default is AutoTune. AutoTune uses machine learning to automatically analyze previous runs of your Spark jobs and choose the configurations to optimize the performance. It'll configure how your data is partitioned, joined, and read by Spark, which can have a significant impact on performance. In fact, we have seen customer jobs running 2 times faster with this capability enabled. We're committed to improving Spark session startup times, and so we're also introducing starter pools in Fabric. Starter pools have default configurations and come pre-wired to your Fabric workspace, meaning you don't have to do anything to set them up. These pools are kept live, meaning they provide users with a Spark session within 10 to 15 seconds of running a notebook, resulting in instant user productivity. Another common customer ask is the ability to reuse Spark sessions across multiple notebooks. With the new high concurrency mode coming soon after public preview, this will now be a possibility. From inside a notebook, users can choose an existing session to attach to, resulting in lightning-fast startup times and lower costs. Coming later this year is the support of high concurrency in pipelines, which will allow you to run multiple notebooks in a pipeline within a single session. Now we have talked about some of the performance enhancements customers can expect. Let's talk about what sorts of controls and configurations are available. Firstly, assuming they have been granted the relevant permissions, workspace admins will have the flexibility of creating custom pools and setting them as the workspace default. They'll be able to configure things like the node size, number of nodes and executors, as well as auto scale. We're also excited to announce that custom pools will start all the way from a single node, enabling customers to efficiently run small or test Spark jobs. This is a great cost-effective option for lightweight workloads. Coming later in the year, workspace admins will also have the opportunity to keep these custom clusters live, which will result in accelerated session start times. Another important aspect of configuring your workload is library management. Workspace admins can install public and custom libraries to the default pool in the workspace. Admins will also be able to set the default runtime and configure their Spark properties. All notebooks and Spark jobs will inherit these libraries, runtime, and settings without needing to manage things on an artifact-by-artifact basis. An upcoming capability that will help users better govern their workloads is policy management. Admins will be able to author policies based on Spark properties to enforce certain rules or restrictions on their workloads, which cannot be overridden, ensuring consistency and compliance. Whilst we want to streamline the process by having default experiences defined at the workspace level, we recognize customers need the flexibility of customizing things at a more granular level too. Later this year, we are therefore introducing a new environment item to give users the customizability they need. In an environment, users will be able to install libraries, choose and configure a new pool, set their Spark properties, and upload scripts to a file system. Environments can be attached to individual notebooks and Spark jobs, giving users the customizability that they need. Let's take a closer look at some of the Spark management experiences in the following demo. Let's take a look at how an administrator can configure a Spark environment for their data engineers. I'm starting out in the Capacity Admin portal, where I can now access the Spark Compute settings for data engineers and data scientists. Opening up the Spark Compute option, I can set a default runtime and default Spark properties. I can also turn on the ability for workspace admins to configure their own custom Spark pools. I'm now going to navigate to the marketing workspace, which I'm getting ready for my data engineers. The workspace comes pre-wired with a default Spark pool that all notebooks and Spark jobs inherit from. We can view and modify this pool by navigating to the workspace settings and drilling into the Data Engineering and Data Science tab. Here I can modify things like the default libraries that come with the workspace. For example, I can search for the word cloud library and choose the version that I want. I can also add libraries from Conda and from YAML files, or upload custom ones directly. Navigating to the Spark Compute settings, I can see that my workspace automatically comes with a default starter pool, and I have full transparency of all the pool details. Without needing to set anything up, all notebooks and Spark jobs can leverage the starter pool to run their jobs. In this case, I would actually like to run some small test workloads, and so I'm going to create a new default pool. I'm going to give the pool a name, and select a small node size and turn auto scale off. I can now set my Spark pool to always run with a single node for my test workloads. Finally, I'm going to reduce my executor upper limit and create the pool. Our workspace admin also has the ability to change the default runtime and modify Spark properties. Now that everything has been set up, I can save my workspace settings. Any new notebooks I create will now automatically use a single node Spark along with the selected runtime, libraries, and Spark properties. We want to ensure developers have a great authoring experience when they work in Fabric. Whether you're a data engineer or a data scientist, you can use notebooks, Spark jobs, or work in your IDE of choice. Let's take a look at some of the capabilities you will be able to leverage. Our primary authoring experience is the notebook. Our notebooks natively integrate with the Lakehouse, making it easy to browse your data and drag and drop it into the notebook cells. Users can easily collaborate with others in real time, whilst the notebook auto-saves their work just like they're used to in Office. Notebooks can be scheduled, or they can be added to a pipeline for more complex workflows. Users who want to make use of ad hoc libraries during their session will be able to install popular Python and R libraries inline, leveraging commands like pip install. This is a quick and convenient way for validating libraries during the development process. Developers can build modularized notebooks that reference each other, and they can also track history through snapshots for troubleshooting errors. Later this year, we're introducing a notebook resource folder where users can store dependencies and helper files like scripts and text. Users can easily upload local files for quick and easy use. Notebooks also provide fully integrated Spark monitoring experiences inside the notebook cells. We also have a unique feature called the Spark Advisor, which analyzes your Spark executions and provides you with real-time advice and guidance. For example, the Spark Advisor can warn you about things like data skew and provide you with guidance and recommendations. Already available is Data Wrangler, a UI data prep experience built on top of Pandas data frames. Any low-code operations carried out are automatically translated to code for transparency and reproducibility. Coming later this year, Data Wrangler will also support Spark, scaling to bigger data volumes, and will integrate with OpenAI for transformations powered by natural language. We also have various improvements coming from a usability perspective. Later this year, we'll introduce a revamped data frame display with built-in summary statistics for easier exploration. We're also working on Power BI integration on top of your data frames, as well as the ability to browse and add code snippets for common data engineering activities. We're excited to announce we're also working on adding native Copilot support to notebooks through constructs like magic commands. Users will be able to leverage these inside their notebook cells to chat about their data or get code generated in the notebook. What's more, Copilot in Fabric is data-aware, meaning it has full context about your Lakehouse tables and schemas. This makes it really easy to have Copilot assist you with your data engineering tasks, as well as helping you better understand, document, and debug your code. Finally, another exciting area of investment is utilizing notebooks not just for development, but also storytelling. Later this year, users will be able to embed their notebooks alongside Power BI reports and dashboards inside Fabric apps, which can easily be distributed to business users. Customers will be able to interact with widgets and visuals in the notebook as an alternative reporting and data exploration mechanism. Let's take a moment to take a look at the notebook developer experience. In this demo, we'll dive deeper into a data developer's authoring experience in Microsoft Fabric. In this project, I'm collaborating with my colleagues on a predictive model built on top of the marketing data in the Lakehouse. I can see Pierre has the notebook open, and I can view his code updates in real time inside the cell. To get started, I'm going to install an ML library I need for my project. Thanks to the built-in live pools, my Spark session starts in a matter of seconds, and I can immediately start being productive. I can now drag and drop my campaign table from my Lakehouse, and a code snippet gets generated for me immediately. As I run my cell, I can leverage the inline monitoring to monitor my Spark job and make sure everything is running smoothly. I can get a preview of my data and use the built-in charting capabilities to explore things and even adjust the charts around for better insights. Next, I can use the display summary function to get a quick overview of the quality of my data, looking at data types, missing values, and summary statistics. I can now leverage Spark to do some additional data cleansing, for example, getting rid of the missing values. Users can also use custom libraries to explore their data further. In this case, we'll plot some box plots to look at data distributions of call durations, broken out by job types and campaign outcomes. The notebook has a built-in resource folder, which makes it easy to store scripts or other code files I might need for the project. I'm going to drag and drop the top feature selector Python script that my colleague created, and I can get a quick overview of the functions it supports. I can now use the top feature selector function to identify the most important features for my model. I can leave my colleagues a comment to the notebook cell, letting them know about my progress. All this time, my notebook is getting auto-saved without any involvement needed from me. I'm now ready to train my machine learning model. After some experimentation with a variety of different model types, I decide to use a logistic regression for this project. Finally, I can plot an ROC curve to evaluate my model's performance, and I can easily store it as an image in my notebook resource folder, so that my colleagues can easily check it out as well. To conclude, Fabric provides me with a rich developer experience, enabling users to collaborate, easily work with their Lakehouse data, and leverage the power of Spark. We know many developers are opinionated about the tools they use and prefer working in IDEs. For this reason, we have invested in VS Code integration as the first IDE we natively integrate with. Users can easily launch the VS Code extension straight from inside the notebook and seamlessly work with their notebooks, Spark jobs, and Lakehouses. Users can run and debug their notebooks either in full local mode or leveraging the Fabric Spark clusters remotely. We're also working on providing a fully remote way of working with vscode.dev, which will be available later this year. In this mode, users can get started with a browser experience with no setup, and changes are instantly reflected back in the service. Finally, customers who want to work completely in their own environment can leverage Fabric purely for submitting their Spark applications. Using the Spark job definition, they can upload their existing jar files, tweak their Spark configurations, and add their Lakehouse references to submit their jobs. Just like notebooks, Spark job definitions come complete with inline monitoring, scheduling, and pipeline integration. Spark job definitions also have the added advantage of being able to specify retry policies, which makes it possible to run long-running streaming jobs with no issues. Combined with Power BI and direct lake connectivity, customers can get an end-to-end solution for near real-time reporting. This wraps up our developer experience announcements. Let's take a look at the pro developer experience before moving on to platform integrations. As a data engineer, I want to work with some of the marketing data in my Lakehouse. Since I prefer working in IDEs, I can make use of the native notebook VS Code integration and open the IDE in a single click. I'm instantly navigated to VS Code and prompted about opening up the Synapse VS Code extension. My marketing notebook is automatically downloaded, opened up, and ready to use. I can easily browse all the notebooks, Spark jobs, and Lakehouses in my workspace, and interact with the notebook I was previously working on in the browser. I have the option of working with my notebook locally, or I can easily connect to the remote Spark cluster in Fabric to leverage the Spark pools I'm already using in the service. I can now start my work in VS Code and run my notebook cells to continue iterating on my project and can seamlessly see the output of my run. In this next step, I can add a breakpoint to my code and leverage all the great debugging capabilities of VS Code for my project. As I debug the cell and hit the breakpoint, I can work with my notebooks just like any other regular local Java or C# script. When I hit the next breakpoint, I can inspect my data frame object in the local call stack on the side and see all the columns, data types, schemas, and more. I can also, of course, keep working in the notebook and adding my own code cells. In this case, let's go ahead and save our cleansed data as a new table in the Lakehouse. In the workspace view, we can navigate through the Lakehouses available, expand out the marketing Lakehouse, and see all the tables we're able to work with. I'm going to run the code cell, and after it's done, let's refresh the workspace view. We can immediately see the new cleansed campaign table appear as a new table in the marketing Lakehouse. Now that I'm done making my changes, I can choose to publish my updated notebook to Fabric. Navigating back to the notebook, let's refresh the browser, and we can see the new table appear in our Lakehouse editor, whilst the notebook has been updated with the latest code changes. In Fabric, we strive to give data developers the flexibility to work in any tool that meets their needs, whether it's our notebooks, VS Code, or in completely external IDE. In this final section, we'll talk about how data engineering is deeply integrated into the Fabric platform. All Fabric workloads sit on top of a shared foundational platform that creates consistent experiences across governance, security, CI/CD, and much more. In this section, we'll deep dive into a few of the platform integrations that are key for data engineers. Firstly, all Fabric items are integrated with enterprise information management capabilities, like lineage, sensitivity labels, and endorsements. You can discover your Lakehouses in the OneLake Data Hub. You can apply sensitivity labels to your notebooks. You can trace lineage of your Spark jobs. Another top-of-mind area is CI/CD. Users are able to connect their workspace to a Git repo, and later this year, they'll be able to commit all their data engineering items, including notebooks, in their native file format, along with any source files. Users are also going to be able to leverage deployment pipelines to deploy their data engineering items across dev, test, and production workspaces, either using the UI or automating the process through Azure pipelines. In addition to inline monitoring experiences, Spark applications are also going to be accessible through the Monitoring Hub, which is the centralized Fabric monitoring portal. Users can get a bird's-eye view of all their items, but they can also drill down to the details at the job level. Customers can also view related items like associated notebooks and pipelines, and also view snapshots of their notebooks for easy troubleshooting. Finally, those who feel at home in the Spark UI can also navigate directly to it, as well as the Spark History Server for viewing native Spark execution metrics. Admins can also get a consolidated view of their capacity reporting, which shows them the utilization of all their workloads in Fabric. This gives admins the clarity and visibility into how much usage all their data engineering items are generating, enabling them to make data-driven capacity decisions. We know how important it is for data engineers to be able to automate their jobs and do things programmatically. The Fabric SDK, which is shipping later this year, enables users to create items, execute jobs, as well as manage and monitor their Spark compute. We'll also support the Livy endpoint for programmatic batch job submission. Before wrapping up, let's take a look at one last demo, this time doing a deeper dive into the monitoring experiences of the platform. Now we'll take a look at how Fabric provides a unified experience for monitoring, whilst giving users the flexibility of diving deeper into their workload-specific needs. I start out by navigating to the Monitoring Hub, which is the centralized monitoring portal for all Fabric items. Users can sort by item type, filter by job status, get more details about a job, and the great part is, this experience is completely consistent for every item, whether it's a data engineering notebook, a data integration data flow, or a Power BI dataset. If there's a job I submitted by accident or I don't want to run anymore, I can also easily cancel the run straight from this experience. Whilst the Monitoring Hub provides me with a consistent way of looking at all my jobs, I can also drill into the details of all my runs, for example, navigating into a specific Spark application. At this point, the experience transforms into something that is personalized per my specific workload. In this case, a data engineer can get all the details of the Spark jobs that are part of their Spark application. If I have a job that has failed, I can easily get the specific code cell snippet of where the problem has occurred. I can also navigate through the diagnostic panel to get more details about where and why the error occurred, but also warnings about potential performance issues. In this case, we can see we have some skewness in the data that the user should look into. Data engineers can also look through the driver logs to get more details about the error. They can also download the logs for further analysis in their own tool of choice. Users can also see the data inputs and outputs, for example, coming from their Lakehouse, blob storage, and other sources. Finally, data engineers can take a look at the notebook snapshot from their run to see exactly where potential issues occurred. For a more scoped view, users can navigate to their workspace and look at the runs associated with a specific item, such as the notebook. And of course, users can monitor their interactive jobs directly inline. Data engineers are also able to navigate to the Spark UI, which shows native Spark execution metrics at the job level. Users can dig into the different executors and check out the corresponding logs. To conclude, Fabric offers many unified experiences ranging from CI/CD to monitoring, where users can benefit from a consistent interface, but can also dive into the workload-specific details if needed. Thank you so much for joining the strategy and roadmap session for Synapse Data Engineering in Microsoft Fabric. As a next step, I highly encourage all of you to try out these new experiences by navigating to fabric.microsoft.com. I would also recommend you check out the data science, data warehousing, and OpenAI session to learn about some of the other exciting announcements. I hope you have enjoyed the session, and I look forward to hearing your thoughts, feedback, and suggestions about the new capabilities we are releasing.